Right, in this video we're going to talk about trigonometric equations. We are going to explain terminology and everything as we work through the examples. So in this set of examples we're going to solve each trigonometric equations. We're going to find first what is called the general solution. We'll explain what that means. Then we're going to find what is called a particular solution in this interval. So these are the equations we have. We are going to do the equations A to E. Then we're going to give you an opportunity to work through F, G, H, and I before you can look at our solutions. Alright, so a general solution is a solution set which includes all the solutions of the given equation. Then a particular solution is going to be a set of solutions in a given interval. So if you like, in terms of a Venn diagram, if this is the general solution, the particular solution is always going to be a proper subset of the general solution. And so it is usual to find the general solution first, and then from there we can extract the particular solution. So let's see how this works out as we go through example number 1. So we are going to do the general solution first. So in example number 1, the equation says sine theta is equal to 1/2. As we solve this equation, the first thing we need to find to ask ourselves is the question: in which quadrant or quadrants is sine positive? Because we can see that sine theta here is 1/2, which is a positive number. And if you remember what we talked about in the first video, then you will recall that sine theta is positive in the first quadrant, is also positive in the second quadrant. So that means the solutions we expect are angles in the first quadrant and an angle in the second quadrant. These two are going to be equal. So remember, these are our ref theta. So what we're going to do is we're going to find the ref theta, and then from there we are going to find the two angles. Ref theta we are going to find by making theta the subject of the formula here. So it's going to be inverse sine 1/2. Okay, we expect two angles, one here and one here. So we are going to have to punch this in the calculator. So again, we make sure that the calculator is in the degrees mode. There is sine, there is inverse sine. So we're going to go second function, and then here we want 1/2 equal. So that gives us 30 degrees. Well, 30 degrees is going to be this one in the first. Well, the ref is 30. Yeah, so maybe let me just write this one here. Okay, ref is 30. So theta, so this is saying this is 30 here, This is 30 there. So theta can either be 30, so that's one of them. It's the one in the first quadrant. The one in the second quadrant, this angle here, if this is 30, then this angle here is going to be 150, which is 30 minus, which is 150, 180 minus 30. So it's going to be 150 degrees. Okay. However, you are going to remember that 30 is coterminal with 390, with 750, etc. You get 390 by adding 30 to 360. So say 30 plus 360, you get 390. If you say plus 360 again, get 750. Say plus 360 again, you get 1110. Alternatively, we could say 30, subtract 360 this time, gives us minus 330. Subtract 360 again, gives us minus 690. So there is many of them, but all of them, we get them by adding multiples of 360. So to include all of them, what we simply do here is we say 30 degrees plus 360 times k, where k is an integer. Okay, so k is 1, this is 360 plus 30, k is 2 is 30 plus 720, k is minus 1 is 30 minus 360. And then we do the same thing with this one. So this is giving us coterminal angles that are solutions of this equation here. And so this is the general solution. Okay, then in part 2, is it part 2 or part B? Yes, in part 2, we only want the solutions in the interval 0 to 360. Okay, so if I do a number line, 0 here, degrees, 360 here, we only need solutions in this interval. So we're going to go back to our general solution. Then we're only going to extract values that fall in this interval here. So it is usual to go into that solution, start with k equals to 0. So for this one, when k is 0, this is 30, and 30 falls in this interval. So we're going to write 30 degrees here. When k is 1, we get 390, but 390 is already this side. Okay, and then when k is negative 1, is 30 minus 360, which is negative 330. That's already falling this side again. So that means in this set of angles, only 30 falls in this interval here. Then we go to these ones. When k is 0 is 150. 150 falls in this interval, so we write 150. Then again 150 plus 360 falls outside this side. 150 minus 360 falls outside this side. So that means our particular solution is going to give us 30 and 150. So that sorts out our example number A. In example number B, we're going to start with part 1. We have cosine theta is negative 0.25. Cosine theta is negative 0.25. Cosine theta is negative 0.25. So this time we're going to ask ourselves, in which quadrant or quadrants is cosine negative? So, and again, if you remember that diagram, cosine is going to be negative in quadrant number 2 and quadrant number 3. Okay, and again, these two are going to be equal. Then the next thing we do, we find ref theta. So ref theta, we're going to find by, whenever this is negative, to find ref theta, we disregard the negative sign. So we're just going to do cosine, inverse cosine, 0.25. So we punch that in the calculator. So inverse cosine 0.25. So that's giving us 75.52. So that's our ref. 75.52. So that means we got 75.52 here, 75.52 there. Okay. So our angle in the second quadrant, okay, is going to be 180 minus 75.52. So that's this one here. And then the one in the third quadrant is going to be 180 plus 75.52. Let's start with the one in the second quadrant. 180 minus 75.52. It's 104.48. So 104.48, and then plus 360k. Then the other one is going to be 180 plus 75.52. 180 plus 75.52. Going to be 255.52, and you can see that's going to be an angle in the second quadrant, because second quadrant goes from 180 to 270. So 255.52 plus 360k. So that's going to be the general solution. Just going to show you how to check that your answer is correct. So after finding the reference angle, let me just go back. So inverse cosine 0.25, that's a ref. Then if I say plus 180 here, 180, okay, that's the exact value of the solution. Then what I'm going to do is I'm going to save this. We talked about this in class, so we'll go store. I'm going to store it in A. So that thing that shows you that we have stored that thing as A. Now, if I say cosine of that, it should give us 0.25. So I could go cosine, recall A equal to, and that's 0.25. And then you can do the same thing with the other one in the second quadrant. Okay, so that's the general solution. Now we need the particular solution. We do the same procedure as before. 104.48 going to be one of them, and the other one is going to be 255.52. Those ones are between 0 and 180. All right, that's example number B. Just going to go through example number C. So in C, we've got tangent theta is 3.1. So in C, we have got tangent theta is 3.1. So again, we ask ourselves the question, where in which quadrant is tangent positive? And the answer should be first quadrant and third quadrant. These are equal. Now, if you remember your geometry, if those are equal, it means this is a straight line. So that means the solutions are going to lie in a straight line. So again, we find a ref theta by doing inverse tangent 3.1. So inverse tangent 3.1, that gives us 72.12. So that means the one in the first quadrant is just going to be 72.12. So theta going to be 72.12. 1 degrees plus 360k. And then the other one is going to be 180 plus 72.12. So 180 plus 72.12. That's 255.12. No, 252.12. So 252.12 plus 360k. Then the particular solution is just going to be 72.12 and 252.12. I think the next example is, well, yeah, it's a, I want to do 2 more examples. Then we're going to give you now actually we're going to stop this video here. We're going to continue in the next video. Don't want the videos to be too long, so D and E we're going to do in the next video.